video is going to be about the machining and setting up of this part here. This is the way the part has been provided to me with the lathe work already done. And I'm going to just do the milling work only on the Mazak Integrex over here. I want to first discuss my thought process of going through what I think about when I first get something like this to do. You know, I look at the drawing, I see what I'm provided with and what I've got to work with, and the orders of operations that I think about before I even get started with the job itself. You got to think about these things. How are you going to go about doing it? Then get together the various holding method, in this case chuck jaws, and the tooling you need to machine the part with. So let's look at the CAD model first, and we're going to see what I think about my thought process, if you will, on how I go about this. Let's go over to the computer and we'll look at the CAD model over here. All right, let's look at what I first start to look at when I'm looking at a part, the model. Now the lathe work is already done, so I don't have to even think about what I'd have to do with that, because that might dictate which way I would start. But all that's already done. As you saw, I showed you the part to begin with, or what I'm starting with. So I'm looking at the drawing, and there are dimensional tolerances between these features on this end and this key slot and a couple of holes here on this end of the part. So I need to maintain some kind of relationship in a angular or rotational type of relationship. So I think it would be better, and this is what my thought, to start on this end with the holes that go all the way through the part. Also, these ports, you can see those holes go all the way through, have a positional tolerance between the holes behind them. So these bores in the front have a close tolerance and finish, like something sealing, going in there and sealing on there. But these holes behind them also have a tolerance in relation to them, as far as a true position tolerance, and then all 8 of them have a true positional tolerance to this OD, which is datum A on this part. So they really need to be done all in the same operation. I wouldn't want to try to, for instance, drill those holes from this end and then try to match them up to this end. That would be kind of a mistake. And the tolerance isn't overly close. It's like a 14 thousandths true position, which means everything has to fall within, you know, that 14 thousandths diameter circle of the ideal position. So that's not too bad. And I think it's at maximum metal condition, which this bore to this bore, which is only a 2 thousandths tolerance. So that allows you another thousandth of an inch depending on the actual size of your bore. So that's not overly close. And then the holes themselves, these bores, I think also have a 14 thousandths true position to datum A, which is the OD. So all of that's not too bad. In fact, these little 440 holes have a closer tolerance of 5 thousandths true position to datum A. So they're actually a closer tolerance for some weird reason. So I'm thinking this end is going to be better to start with, because I can do these features and mill these features on the OD, and then when I turn the part around, I can indicate on something I've already done here and get my C0, if you will, when I put in these other features, and everything will be aligned to each other. So that's the plan, probably, to start on this end. Now, there is a couple of things that have to be done in a certain order on this end. There's, of course, these holes that go all the way through, and they could be done at any time, really, in relation to each other, because they're not a problem, but it's the holes that intersect these ports. Let me see if I can select something and we can look at a section through here. Okay, let me get a plan view of this. So these holes, these angular holes, have to be intersecting some of these ports on the OD of the part here, and it would be better to at least drill and mill these flat bottom holes at the bottom of these SAE ports first before drilling these long holes to intersect them. It's better to drill into a hole like this than to drill this hole and have the drill and tools coming down and intersecting that hole at the bottom of this other hole. That would be harder on the tooling. So I'm thinking to put these holes in first before I drill these angular holes. Now this particular bore has a 1/2 thousandths tolerance and a good finish required on this, so I'm going to bore that with a boring head. This is my thought processes anyway. So that's what we're going to do there, but there is one hole on this. Let's see if I can position this so we can look at it. There's this hole right here. If I can highlight it, that's got to be put in before you machine this port here. It could be done after this port's machined in there, or this counter bore. This isn't really a port. This is just a counter bore above the SAE port, and the rest of this feature here is the SAE port, and then there's a thread below on an SAE port that it's not shown on the model here, but there's two different size SAE ports. These three here, this one, and this one are number 3 SAE ports, and this is a number 2 SAE port. And so they have the number 2 has a 5/16 24, and the number 3 has a 3/8 24, I believe, on the thread. So those both, all three of those, and this one here can be done with the same thread mill, which is kind of nice. But this hole here, I think it's 109 thousandths diameter, would really need to be drilled in first. So I'd mill a small flat here and then spot drill it and drill through into here, just no deeper than I had to, so that when I drill this hole coming in this direction, I'm not intersecting that hole, or if I am, very little, if I am at all. And these 5 holes here are just spanner wrench holes. They're not too critical. So there's an order of operations that has to be done here. I've got to do this first, probably, before I do the OD port holes, and then I would come back with these 3 angular holes here, here, and here, drill them in to intersect those. And as far as these holes go, I'm going to also drill them with a gun drill, the longer holes that go all the way through, cut that section through here again. Because I have found I have a lot less difficulty with drilling longer holes. This part is 8 inches overall in length, and the material is 662 titanium. So to drill 8 inches through with, this is a 200 the hole is dimensioned 200 thousandths, but it's plus or minus 10, and I'm going to drill them with a 203 size drill. It's just a standard size drill, and I happen to have those. And I'm going to drill probably halfway through to begin with a short gun drill, and then drill the rest of the way through with a longer gun drill. And I may not even drill all the holes with the same drill. I might drill maybe 4 of them with a short drill, and then switch to another drill, drill the other 4, and then come in with a longer drill and do the same thing with 2 longer drills, because it may not. I'll have to see when I do the first part how the drills hold up. I may be able to do it with 1 of each drill. I'm going to see, and then I'm going to drill this with a twist drill down to here. But like I said before, the normal twist drills don't have a 120-degree angle on them anymore, and this is dimensioned at 120 degree. And with this radius, so I've ground a form tool to actually just form the bottom of this hole mostly after I drill it down to as close as I can to the depth. And then I'm going to mill these bores here. I think they have a plus or minus 2 thousandths tolerance, plus or minus 1, no, plus or minus 1 with a 32 finish, I believe. And I think I can mill that okay on the Mazak. I think that won't be a problem. And they're not very deep. And this radius doesn't really even have to be there. They said that's a maximum dimension, and it can be anything from a sharp corner to a radius. So I'm just going to not worry about the radius, and then of course I'll mill this 30-degree chamfer in the hole. This has to have a 32 finish, so it has to be pretty good there. But I don't think there'll be a problem with just milling that in there. So that's the kind of what I'm looking at in the plan of operations here. I'm going to, of course, mill these 440 holes in first, and then tap them by hand if I have to, if I can't get them to gauge. And really the most difficult part of this is going to be when we turn it around. And there's these 632 holes here, but they want a 410 thousandths depth of thread on the 632, and that's going to be a little bit tricky in titanium. I'll probably mill it in there. I'm going to mill it in there with a thread mill, and I'll probably have to hand tap it to get it to gauge. That's usually what happens with this titanium. So that's kind of the plan. There's got to be a little bit of engraving done on this OD, and I think there's some engraving on this end, numbers on the holes. So let's look at the tools and see what we got to deal with and what I've got for the tooling.
So let's go over here and look at the tooling. Oh, first let's look at this setup here. This is what how I'm going to hold the part for the first operation. I'm going to chuck onto it up to here, and so I still have access to this OD. I've relieved these chuck jaws back so I can get down in here with my tools and not run into the jaws on the OD holes here. I've made this little aluminum setup piece. I didn't really, finish it exactly like the titanium part because that's not necessary for the milling. I just did enough so that I can set my milling up, and I haven't even drilled this hole all the way through or anything, just deep enough so I can mill my key slot in here, and the same thing on the other side. You can't really see it in here, but I put a small counterbore in there so that I can set up just the key thing. And I'm using this smaller 8-inch chuck here so that I can get my spindle down, because the spindle of this machine is like 12 inches in diameter, and when it's indexed down at 90 and I'm coming down here, if I'm in the big chuck here, I have to use long tools because I'm going to be hitting my chuck jaws to reach down to the part. So I've made this little smaller chuck extended out on this arbor kind of thing, so that I can do parts like this that are smaller for that reason. But let's go look at the tools now. All right, here's the two SAE port tools. Let's start here. They're a number 3 and a number 2 SAE port. I made this tool on my CNC tool and cutter grinder, so it's out of a solid carbide blank. But the normal tool, like this, is a standard SAE port tool you can buy from some tooling place, and the standard one looks like this. This is a number 2, but they're both the same. The number 2 and the number 3 look like this. As you can see, it's a carbide tip silver soldered onto a steel shank. But I've ground this one down so it'll fit into those counter bores. See, it normally is this big and it wouldn't fit in there. So I had to modify those two tools. Also had to grind a little bit off the end of this for one of the ports because it's a little bit shallow for the standard length as well. So those two I modified, and then here's this tool that I ground to do the bottom of that one hole that I talked about in the CAD model, with the 120 degree angle and the 30 thousandths radius into the 203 thousandths hole. So that's that tool. And here's I'm going to bore that 3/16 counter bore with these this PH horn tool, which let me get the boring head. It's the ITS boring head. I've modified this shank. I cut it off and put a bushing in here because it wasn't the right size of this PH horn shank to fit into the boring head. And I can mount this tool in there. I'm not going to use this one. I'm going to use this one because the hole is smaller and deeper than this tool can handle. and this seems to work pretty good. I've used this in the past for other things. So that's how I'm going to bore that bore there. And then the thread mills, I'm going to use this 24 pitch thread mill for the SAE ports. And here's the thread mill I got to use for the 632 thread. Now you can get an idea of how deep that thread is, because it's going to take all this length of this thread mill to reach down to that depth. If there's any designers watching this, I don't know why anybody would specify that deep a thread on a 632, but that's why I'm saying that's going to be a little bit difficult in this titanium material to handle. So that's for the 632 thread. And here's the thread mill I'm going to use for the 440 thread, which is a 1/4 inch deep, which is what is necessary here on that. And then all these other tools are the drills necessary for the various holes to start the gun drills, to do other things in this part. I'm going to use this small gun drill here to drill that angle hole that between those two ports that you saw in that section. And here are the other various gun drills I need. Now let's look at a gun drill for just a second, and let me explain something about a gun drill. When you buy a gun drill, they specify the drill as the length, which is the overall length of a gun drill, and you have to subtract off the shank and this little bit of an imperfection in the flute to get your drill depth. So this is a 12-inch gun drill, and it'll really only drill about 8 inches deep, which is perfect for this part because the part's 8 inches. So if you're looking at the part, it'll drill all the way through without a problem. But you got to realize this about gun drills is they specify them as the overall length, including the shank. So keep that in mind if you ever buy a gun drill as to your drill depth. So that's the longer gun drill, and this will be the shorter one, the 203 size. And then I need some 3/16 ones for those angle holes, and a 5/32 drill for the other angle hole. So that's basically the tooling I need. Now it looks like a lot of tooling, but these type of parts require quite a few tools to be set up to do them. So that's probably going to be it for this video. The next video, we're going to set these tools in holders and finish up the programming and machine the parts, or at least machine the first operation, I should say. I'm going to just add this little, I guess you might call it a semi-mild rant, I guess, at the end of this video. Not really a rant, but I get quite a few comments on the videos about the way I do things, the efficiency of it, it's, you know, they could do it faster, and things like of that nature. And I want to just kind of explain where I'm coming from on the way I do work. Now, in the past, when I had a bigger shop and I had, you know, like 50 employees, it was important. You know, we had to make the best use of time. We could be losing money because you're paying employees. You have overhead expenses and everything like that, and shop time and all that, and rent, machine payments, everything. And it is important. You know, these comments aren't really incorrect, but in my case, I don't really worry so much about that, because the way I do work, everything I have is paid for. I do pay some rent for this space. So if I wasted my time and spent more money than the rent, yes, I would lose money on the rent. But in general, that doesn't really happen. I buy tooling, and I don't usually buy material. Occasionally I buy material, but most of the time I don't even buy material. So I'm just buying tooling, and I'm spending my time to do the work. And in my rent is included, you know, like air compressor and utilities and everything. So
that's all combined in one. So I don't really have the or put it another way, I have the luxury of not worrying so much about being ultra efficient on time and doing things the fastest way possible. More important to me is doing them correct the first time, and not scrapping the material, or breaking tooling, or damaging the machine, or something of that nature, rather than ultimate speed. Now, those comments people make are not incorrect. They're right if you have the situation where you are paying people and you have expenses you have to pay for and everything. Yes, you have to be more careful about the time it takes to do things. But in my case, I'm not showing you in my videos the most efficient way to do things or the fastest way or anything like that. Go watch Titan or somebody like that if you want to see that. That's not what I'm showing you. I'm showing you the way I do things because I can afford to do them this way. If I have this X amount of dollars left after I buy tooling and I pay my rent, I don't really lose money. I might spend more time and I might make less per hour, but to me, I'm worried about this hourly rate as much as getting the job done. And at the end of the month, I did so many jobs and I made these X number of dollars. If I spend more time to do it, that's my business, and I'm not worried about it so much. It doesn't bother me that much. So, you can make the comments, and they're not invalid comments, I guess you'd say, but it doesn't really apply to me the same as maybe you guys or whoever is making these comments. So I just want to say that because it does get a little bit annoying, to have these comments all the time and people telling you, you don't know what the hell you're. Well, I do know how to do things faster, but I don't necessarily drive myself to do things faster as much as do things the first time correctly, and then I don't have to worry. And I want to be a little bit more comfortable. I worked all these years with a bigger shop, sold the shop, and I want to be a little bit more comfortable in the way I'm doing work and not be stressed out on the feed hold button all the time or something like that. So I just want to say that it's a little bit of a rant, I guess you'd say, about these comments. Most of you guys are very positive in your comments, and I appreciate it. And also, I have found that in doing the videos, like I'll do a few videos on this little part, and it kind of helps supplement the job. And it definitely does on some jobs. That video where I was machining a shaft with a flange on the end of it, which has like 2.5 million views, maybe, I don't know, 2.4 million views. I've made more money on that video than I have on the job. So in a way, the videos are sort of supplementing the jobs if I can make videos on the job, and it helps offset maybe the time I'm taking, like people say, to do the job. And it's kind of working out now. In the beginning of my YouTube channel, I didn't hardly make any money, but now I'm starting to make a little bit more money. I probably average about $2,000 to $2,500 a month on my AdSense money, which is not tons, but it actually supplements the job. So if I do videos on this job and I make an extra $500 or $1,000 on the group of videos, then it supplements the job, and it's kind of nice. I didn't even think in terms of this when I first started doing this YouTube channel, but now I can kind of, in a way, think in that direction if I'm allowed to make videos on a certain part, and it can help earn a little money, extra money on the part, and I don't have to be so worried about that I'm making so many dollars per hour, if you will, on the part. Although the videos do take a little bit of time to make, and thank you to everybody that must let the ads play through or whatever, however that works. I don't know. I don't see ads on my channel because I pay for the premium. That's like $10 a month, and I don't watch ads. But whoever's watching the ads or letting them play through, it's a little bit of extra income that I get for the particular jobs is the way I'm starting to look at it. And it's kind of nice. Like on the one video on the shaft, I made more money on the video than I did on the job. So that worked out real good. So thank you for watching the videos, and possibly if you watch the ads. I don't care if you watch the ads or not, but you know, it does earn me a little bit of extra income. So thanks for that.